Welcome back, dear viewers. Today we're diving back into the world of prehistoric monsters that we're all better off extinct. Before we begin, don't forget to hit that subscribe button and check the description for a link to part 1 where I covered 10 other terrifying creatures from the past. Arthropleura. The Carboniferous period, roughly 300 million years ago, was a time of towering ferns, vast swamps, and oxygen levels far higher than today, a perfect recipe for giant arthropods. Among these ancient titans, none were more impressive than Arthropleura, a 2-meter-long armored millipede that looked like a biological tank. With its heavily segmented exoskeleton, dozens of legs, and sheer bulk, it remains the largest known land invertebrate in Earth history. While modern millipedes are harmless, detritivore creatures that curl up when threatened, Arthropleura was a behemoth that could have crushed small amphibians and early reptiles under its weight without even noticing. Arthropleura thrived in the warm, humid forests of what is now North America and Europe, where dense vegetation and decaying plant matter provided an abundant food source. Unlike its modern relatives, it did not just nibble on leaf litter. It likely plowed through it, its massive body leaving deep tracks in the soft, wet soil. Fossilized trackways, some as wide as 50 centimeters, suggest that these creatures moved in groups, their countless legs working in unison like a living conveyor belt. Scientists estimate that Arthropleura could have weighed over 50 kilograms, making it not just long but also incredibly heavy for an arthropod. One of the most fascinating aspects of Arthropleura is how it grew so large. The key factor was the oxygen-rich atmosphere of the Carboniferous, which allowed arthropods to reach sizes impossible today. Insects and other invertebrates rely on passive diffusion through tiny tubes called tracheae to breathe, and higher oxygen levels enabled them to grow far beyond modern limits. Some dragonflies of the time had wingspans of nearly a meter, and Arthropleura took this gigantism to the extreme. Its body was covered in tough overlapping plates that acted like natural armor, protecting it from potential predators, though in its prime there were few creatures big or bold enough to attack it. Despite its intimidating appearance, Arthropleura was probably not a predator. Unlike its distant carnivorous relative Pulmonoscorpius, a giant scorpion, Arthropleura's mouthparts suggest a diet of rotting vegetation, fungi, and possibly algae. However, some scientists speculate that it might have occasionally scavenged carrion or even supplemented its diet with small animals. Imagine a millipede the size of a couch accidentally crushing a lizard while foraging. Even if it wasn't an active hunter, its sheer size would have made it a dominant force in its ecosystem. So why did this armored giant disappear? The answer lies in the changing climate. As the Carboniferous gave way to the Permian period, Earth climate became drier and oxygen levels dropped. The vast coal swamps that sustained Arthropleura shrank, and the towering forests receded. Without the high humidity and abundant plant matter it needed, Arthropleura could no longer survive. Additionally, the rise of early reptiles and larger predators may have put pressure on younger or smaller individuals. By the time the Permian was in full swing, Arthropleura was gone, leaving behind only fossilized segments and trackways as evidence of its once mighty reign. Today we should be thankful that Arthropleura is extinct. While it was not a bloodthirsty monster, a creature of its size roaming modern forests would be a terrifying sight. Imagine encountering a millipede longer than a human is tall, its armored body rustling through the undergrowth. Even if it was not aggressive, its sheer mass could make it a hazard. Stepping on a regular millipede is one thing, but disturbing a 2-meter-long version might provoke a defensive reaction strong enough to knock a person over. Beyond the fear factor, such a giant arthropod would disrupt ecosystems, outcompeting smaller decomposers and potentially altering soil health. Arthropleura remains one of the most striking examples of Earth prehistoric weirdness, a time when invertebrates grew to sizes that seem impossible today. Its existence reminds us how drastically environmental conditions can shape life, and its extinction underscores the fragility of even the most dominant species. While it is fascinating to imagine a world where millipedes were the size of canoes, it is probably for the best that we only encounter them in fossil form. The Carboniferous had its share of giants, but in the modern world we are better off with millipedes that stay small enough to fit in the palm of your hand. Purussaurus. The Miocene epoch was a time of monstrous reptiles, and none were more terrifying than Purussaurus, a bus-sized crocodilian that dominated South American waterways 8 million years ago. This prehistoric behemoth stretched over 12 meters long and weighed an estimated 8 to 10 metric tons, making it one of the largest crocodilians to ever exist. Its skull alone measured 1.5 meters long, armed with conical teeth designed for crushing bone and tearing flesh. Unlike modern crocodiles that rely on ambush tactics, Purussaurus was an apex predator capable of taking down large mammals, turtles, and even other crocodilians with terrifying efficiency. Purussaurus thrived in the vast wetland ecosystems of what is now the Amazon basin, where warm, shallow waters and abundant prey created ideal conditions for a superpredator. Fossil evidence suggests it shared its habitat with giant rodents, ground sloths, and early primates, all potential meals for this aquatic nightmare. The sheer size and power of Purussaurus meant it had no natural predators as an adult, ruling the food chain with absolute authority. Its hunting strategy likely involved a combination of brute force and patience, using its massive bulk to drag prey underwater in a death roll or crush them with one of the most powerful bite forces in history, estimated at over 11,000 pounds per square inch. The extinction of Purussaurus was linked to dramatic environmental changes at the end of the Miocene. As the Andes Mountains continued to rise, the Amazon basin underwent significant shifts in drainage patterns and water availability. The once expansive wetlands began to fragment, reducing the habitat and prey base for massive aquatic predators. Additionally, cooling global temperatures and increased competition from other predators, including newly evolved mammalian carnivores, likely contributed to its decline. By the Pliocene epoch, Purussaurus had vanished, leaving only fossilized remains as proof of its reign. Modern ecosystems would struggle to support a predator like Purussaurus. Its enormous size and appetite would devastate aquatic life, potentially collapsing fish populations and endangering large mammals that venture near water. Human settlements along rivers would face constant threat, as a crocodilian of this scale could easily capsize boats and drag victims underwater with little resistance. Even modern saltwater crocodiles, which max out at 7 meters, are responsible for fatal attacks. Imagine a creature nearly twice that size lurking in murky rivers. Beyond the immediate danger to humans, Purussaurus would disrupt entire food chains. Its need for massive prey would put pressure on large herbivores, while its territorial nature would displace smaller predators. The ecological balance that supports modern crocodilian species would collapse under the demands of such a gigantic carnivore. Purussaurus represents a time when reptiles ruled with unchallenged dominance, a relic of Earth's more brutal past. Its extinction allowed for the diversification of mammals and the eventual rise of human civilization. While its existence fascinates paleontologists, the modern world is far better off without a 12-meter crocodilian patrolling its waterways. The Miocene may have been the age of Purussaurus, but thankfully that age is long over. Dunkleosteus. The Devonian period witnessed the rise of one of the most formidable predators in Earth's history, Dunkleosteus. This prehistoric armored fish dominated ancient oceans with its terrifying combination of size, strength, and devastating bite force. Reaching lengths of up to 10 meters and weighing over 4 tons, Dunkleosteus ruled the seas approximately 360 million years ago during the late Devonian period. Unlike modern fish with conventional teeth, this ancient terror possessed a unique set of self-sharpening bony plates that formed a nightmarish cutting apparatus capable of generating bite forces estimated at 8,000 pounds per square inch. Dunkleosteus belonged to a group of armored fish called plecoderms, characterized by their thick bony plates covering the head and thorax. The creature's most distinctive feature was its jaw mechanism, two pairs of sharp bony plates that functioned like industrial shears. These plates continuously ground against each other, maintaining razor-sharp edges that could slice through flesh and bone with terrifying efficiency. Modern research using biomechanical modeling suggests the bite force of Dunkleosteus was powerful enough to potentially cut through steel cables of moderate thickness, making it one of the most powerful biters in vertebrate history. This ancient predator inhabited shallow seas that covered large portions of what is now North America, Europe, and northern Africa. Fossil remains are particularly well preserved in the Cleveland Shale Formation of Ohio, providing scientists with detailed information about its anatomy and lifestyle. The marine ecosystems of the Devonian period featured an abundance of armored prey, and Dunkleosteus was perfectly adapted to hunt them. Its diet likely included other placoderms, early sharks, and various bony fish that shared its environment. The predator's hunting strategy probably involved ambush attacks, using its powerful tail for sudden bursts of speed to overtake prey before delivering a crushing bite. The physical characteristics of Dunkleosteus reveal much about its predatory lifestyle. Its heavily armored head and thorax provided protection during violent encounters with prey, while the unarmored rear portion of its body allowed for greater flexibility and swimming efficiency. Unlike most modern fish, Dunkleosteus lacked true teeth. Instead, its jaw plates formed sharp cutting surfaces that could slice through the toughest armor of other Devonian sea creatures. Recent studies suggest Dunkleosteus may have been among the first vertebrates capable of suction feeding, rapidly expanding its mouth cavity to draw prey closer before delivering the killing bite. The extinction of Dunkleosteus occurred during the late Devonian mass extinction event, one of the Big Five extinction events in Earth's history. This catastrophic period saw dramatic changes in ocean chemistry and widespread anoxia, oxygen depletio in marine environments. The exact causes remain debated, with potential factors including massive volcanic activity, asteroid impacts, or drastic climate changes. As marine ecosystems collapsed, large specialized predators like Dunkleosteus were particularly vulnerable. Their dependence on specific prey and stable environmental conditions made them unable to adapt to the rapidly changing world. The disappearance of Dunkleosteus and other placoderms paved the way for the rise of modern fish groups, including the ancestors of today's sharks and bony fishes. The modern marine environment is unquestionably better off without Dunkleosteus. A predator of such size and power would wreak havoc on contemporary ocean ecosystems. Its appetite would devastate fish populations, potentially collapsing commercial fisheries and disrupting marine food webs. The creature's powerful jaws could damage underwater infrastructure, from submarine cables to offshore drilling equipment. Even if direct attacks on humans were rare, the mere presence of such a predator would make ocean activities significantly more dangerous. The extinction of Dunkleosteus allowed for the development of more balanced marine ecosystems where no single predator holds such overwhelming dominance. From an evolutionary perspective, Dunkleosteus represents an extraordinary but ultimately doomed branch of vertebrate development. Its heavily armored body and specialized feeding apparatus were perfectly adapted to its time, but lacked the flexibility needed to survive environmental changes. The disappearance of such specialized predators created opportunities for more adaptable fish groups to diversify and eventually give rise to modern marine life. While Dunkleosteus remains one of the most impressive examples of prehistoric predation, its extinction was a necessary step in the evolution of marine ecosystems. The Devonian seas may have belonged to this armored terror, but today's oceans function without such nightmarish predators, a fact for which both marine life and humans should be profoundly grateful. The fossil record of Dunkleosteus serves as a powerful reminder of nature's capacity for creating perfect predators, and equally of the impermanence of even the most dominant species. Therizinosaurus. The late Cretaceous period hosted some of the most unusual dinosaurs, but none were as perplexing as Therizinosaurus. This massive theropod stood out for its bizarre combination of features: a pot-bellied, slow-moving body covered in feathers, topped with a small head and armed with the longest claws of any known animal, curved blade-like appendages reaching up to 60 centimeters in length. Initially mistaken for a giant turtle when its claws were first discovered in the 1950s, Therizinosaurus has since been recognized as one of evolution's most peculiar experiments. Therizinosaurus lived approximately 70 million years ago in what is now the Gobi Desert of Mongolia, sharing its environment with famous contemporaries like Velociraptor and Protoceratops. Unlike its carnivorous relatives, Therizinosaurus belonged to a group of theropods that transitioned to herbivory or omnivory. Standing nearly 5 meters tall and reaching lengths of 10 meters, it was among the largest of the Therizinosaurids. Its most striking feature, those enormous claws, were likely used for stripping vegetation, defending against predators, or possibly digging for roots and insects. The claws were so long that the animal would have needed to walk with its hands turned inward to avoid dragging them on the ground. The lifestyle of Therizinosaurus has been the subject of much debate. Its small head and leaf-shaped teeth suggest a primarily plant-based diet, but the sheer size and shape of its claws have led some scientists to speculate it may have supplemented its meals with small animals or eggs. The creature's broad, barrel-shaped torso housed an extensive digestive system needed to process tough plant matter, while its long neck allowed it to browse vegetation at different heights. Despite its terrifying claws, Therizinosaurus was likely a slow-moving animal, relying more on intimidation than speed to deter predators like Tarbosaurus, the apex carnivore of its ecosystem. The extinction of Therizinosaurus, like all non-avian dinosaurs, came with the catastrophic asteroid impact 66 million years ago. The global devastation that followed, wildfires, acid rain, and prolonged winter conditions, wiped out creatures that couldn't adapt quickly enough. Therizinosaurus, as a large, specialized herbivore, was particularly vulnerable to the sudden collapse of plant ecosystems. Its disappearance marked the end of one of the most unusual evolutionary branches of theropod dinosaurs. Modern ecosystems would struggle to accommodate a creature like Therizinosaurus. Its size and dietary needs would put immense pressure on vegetation, potentially deforesting large areas. Those enormous claws, while primarily used for feeding, could easily become lethal weapons if the animal felt threatened. Imagine encountering a feathered, elephant-sized dinosaur with meter-long claws. Even a defensive swipe could be catastrophic. Additionally, Therizinosaurus would face constant conflict with human agriculture, as its feeding habits would devastate crops and orchards. From an ecological perspective, the world is better off without such extreme specialization. Therizinosaurus represents a time when dinosaurs could evolve into highly niche forms, but such specialization often comes at the cost of resilience. Its extinction, while part of a broader tragedy, allowed mammals to diversify and eventually give rise to the modern world's more balanced ecosystems. While paleontologists marvel at Therizinosaurus as one of nature's most fascinating creations, its absence today is something for which both the environment and humanity should be grateful. The fossil record of this clawed giant serves as a reminder that evolution can produce truly extraordinary forms, but also that even the most remarkable creatures are not immune to extinction. Phorusrhacos. The Cenozoic era witnessed the rise of one of the most terrifying avian predators to ever walk the earth, Phorusrhacos, a 3-meter-tall flightless carnivore known as a terror bird. This apex predator dominated South America for millions of years during the Miocene epoch, approximately 20 to 13 million years ago. Unlike modern birds, Phorusrhacos was a hyper-carnivorous hunter with a massive hooked beak, capable of crushing bones and severing spinal cords. Weighing up to 130 kilograms, it combined the speed of an ostrich with the killing prowess of a velociraptor, making it one of the most formidable predators of its time. Phorusrhacos belonged to a family of large flightless birds called Phorusrhacidae, which evolved in isolation on the island continent of South America. Its physical characteristics were perfectly adapted for hunting. Long, powerful legs allowed it to reach speeds of 50 kilometers per hour, while its reduced wings were likely used for balance during high-speed pursuits. The most fearsome weapon was its enormous skull, nearly 60 centimeters long, equipped with a deep, curved beak that functioned like a hatchet. Studies of its close relatives suggest it may have used its beak to deliver precise, devastating blows to prey, similar to how eagles kill with their talons, but on a much larger scale. The hunting strategy of Phorusrhacos has been reconstructed through biomechanical studies in comparison with modern predators. Unlike ambush hunters, terror birds were likely pursuit predators that relied on stamina and speed to run down prey. Fossil evidence suggests they primarily hunted medium-sized mammals like the thurium, a prehistoric relative of horses, and even competed with marsupial predators of the time. Their attack method probably involved chasing prey to exhaustion, then using their powerful legs to pin the victim while delivering fatal blows with their massive beaks. Some paleontologists theorize they may have swallowed small prey whole, as their beak structure shows similarities to modern sirenias, which employ this feeding strategy. The reign of Phorusrhacos ended when the Isthmus of Panama formed around 3 million years ago, connecting North and South America in an event called the Great American Biotic Interchange. This land bridge allowed saber-toothed cats, wolves, and other placental mammals to invade South America, outcompeting the native terror birds. Climate changes during the Pliocene may have also played a role, as open grasslands replaced the forests terror birds were adapted to hunt in. The last known terror birds disappeared about 1.8 million years ago, unable to compete with the more efficient mammalian predators. Modern ecosystems would be devastated by the presence of Phorusrhacos. As an apex predator with no natural enemies, it would decimate populations of deer, wild boar, and even livestock. Human settlements near its habitat would face constant threat. A bird of this size and aggression could easily kill an adult human with a single strike. Its territorial nature would make it a significant hazard in rural areas, and attempts to control its population would prove extremely difficult given its speed and intelligence. From an ecological perspective, the extinction of terror birds allowed for the development of more balanced predator-prey relationships in South America. While impressive, Phorusrhacos represented an evolutionary path that became obsolete when more efficient mammalian predators arrived. The world is undoubtedly safer without 3-meter-tall predatory birds capable of outrunning Olympic sprinters. The fossil record of Phorusrhacos serves as both a testament to nature's creativity and a reminder that even the most dominant predators are not immune to extinction when their environment changes. While fascinating to paleontologists, this terror bird's absence is something modern humans and ecosystems can be grateful for. Meganeura. During the Carboniferous period 300 million years ago, Earth's atmosphere contained significantly higher oxygen levels, allowing arthropods to reach sizes unimaginable today. Meganeura represents one of the most spectacular examples of this phenomenon, a dragonfly-like insect with a wingspan reaching 65 centimeters, comparable to a modern hawk. These giant flying predators dominated the humid coal forests of what is now Europe, where they patrolled the airspace as apex aerial hunters. Fossil evidence from France and England reveals creatures so large their wing movements would have produced audible humming sounds as they hunted smaller insects and possibly even small amphibians. Meganeura belonged to an extinct group of insects called griffinflies, distant relatives of modern dragonflies. While similar in body plan to today's odonates, Meganeura differed in several key aspects. Its wings featured a more primitive vein structure and lacked the specialized nodus found in contemporary dragonflies. The creature's body could reach lengths of 40 centimeters, supported by 6 spiny legs adapted for grabbing prey mid-flight. Studies of its compound eyes suggest exceptional visual acuity, necessary for tracking fast-moving targets in the dense carboniferous forests. The insect's mandibles were strong enough to crush the exoskeletons of large prey, including other giant arthropods that shared its ecosystem. The flight mechanics of Meganeura have fascinated scientists for decades. Recent aerodynamic studies indicate it likely flew differently than modern dragonflies, with slower wing beats but greater gliding ability. Its size would have made it vulnerable to wind currents, suggesting it hunted primarily in the sheltered understory of giant lycopsid trees. The high oxygen atmosphere, estimated at 30 to 35% compared to today's 21%, allowed its tracheal respiratory system to function efficiently at such large sizes. Some researchers propose Meganeura may have been territorial, patrolling specific areas of the forest and engaging in aerial battles with rivals. The extinction of Meganeura coincided with the end Carboniferous drop in atmospheric oxygen levels. As the climate became drier and oxygen concentrations decreased, the respiratory systems of giant arthropods could no longer support their massive bodies. The replacement of swampy coal forests with different vegetation types also destroyed Meganeura's preferred habitat. Smaller relatives survived and eventually evolved into modern dragonflies and damselflies, but the age of giant flying insects ended permanently. The Permian period that followed introduced new predators, like early reptiles, that may have preyed on giant insect nymphs, further ensuring their disappearance. Modern ecosystems would face significant challenges if Meganeura still existed. A flying predator of this size would decimate populations of birds, bats, and beneficial insects. Agricultural areas would suffer as swarms of giant carnivorous insects consumed pollinators and destroyed crops. The mere presence of hawk-sized flying insects would make outdoor activities hazardous. Their powerful mandibles could deliver painful bites to humans. Air traffic would need to account for collisions with creatures large enough to damage aircraft engines. Public health systems would struggle with the psychological impact of giant insects patrolling urban skies. From an evolutionary perspective, Meganeura represents a unique adaptation to specific environmental conditions that no longer exist. Its disappearance allowed for the development of modern insect ecosystems dominated by smaller, more numerous species. While fascinating as a fossil specimen, the world benefits from its absence. The Carboniferous period demonstrated how oxygen levels can drive gigantism in arthropods, but also how vulnerable such specialized creatures become when conditions change. Meganeura's fossil record serves as both a testament to evolutionary innovation and a reminder of nature's delicate balance. Contemporary humans can appreciate studying these magnificent creatures through fossils, while being profoundly grateful they don't share our skies today. The legacy of Meganeura continues to influence science, providing insights into paleoclimatology, biomechanics, and evolutionary biology. Engineers study its wing structures for biomimetic applications, while climate researchers use it as an indicator species for past atmospheric conditions. However, its extinction remains an important case study in how environmental changes can eliminate even the most successful species. The modern world, with its lower oxygen levels and different ecosystem structures, simply couldn't support such gigantic flying predators, a fact for which both human civilization and current biodiversity can be thankful. Woolly rhinoceros. The frozen landscapes of the Pleistocene epoch were home to one of the most formidable megafauna, the woolly rhinoceros, Colodonta antiquitatis. This massive creature, weighing up to 2,700 kilograms and measuring 4 meters long, roamed the mammoth steppes of Eurasia alongside iconic species like woolly mammoths and cave lions. Unlike modern rhinos, the woolly rhinoceros was specially adapted to Ice Age conditions, sporting a thick, shaggy coat and a massive flattened horn that could grow over 1 meter in length. Fossil evidence and cave paintings reveal an animal built like a living tank, stocky, muscular, and likely highly aggressive when threatened. The woolly rhinoceros thrived across a vast range stretching from Scotland to Siberia, with particularly well-preserved specimens found in frozen deposits in Russia. Its most distinctive feature was the enormous anterior horn, which showed signs of wear patterns suggesting it was used for sweeping snow to access vegetation, battling rivals, and possibly defending against predators like cave hyenas. The animal's body was covered in dense fur and a thick layer of fat, insulating it from temperatures that plunged below -40 degrees Celsius. Studies of tooth wear indicate it was a specialized grazer, feeding primarily on tough, fibrous grasses that dominated the Ice Age steppes. Unlike modern rhinos, its legs were proportionally shorter and more robust, providing stability on slippery terrain and helping it power through deep snow. Behavioral reconstructions suggest the woolly rhinoceros was likely solitary and highly territorial. Cave art from early humans often depicts these creatures in aggressive poses, with their heads lowered and horns thrust forward. Fossil evidence of healed injuries on specimens indicates frequent violent encounters, possibly during mating competitions or territorial disputes. The animal's olfactory bulbs were highly developed, suggesting it relied heavily on smell to navigate its environment and detect threats, an essential adaptation in the often foggy, snow-covered landscapes it inhabited. The extinction of the woolly rhinoceros occurred around 14,000 years ago, coinciding with the end of the last glacial maximum. Climate change played a significant role as warming temperatures transformed the mammoth steppe into forests and wetlands, destroying its primary food source. Human hunting pressure may have contributed, as evidenced by rhino remains found at Paleolithic campsites. The combination of shrinking habitat and increased human presence proved fatal for this Ice Age giant. Unlike some cold-adapted species that migrated north, the woolly rhinoceros had no suitable refuge. Its specialized adaptations became liabilities in the changing world. Modern ecosystems would struggle to accommodate the woolly rhinoceros. Its size and territorial nature would make it a dangerous neighbor, capable of charging at vehicles or destroying infrastructure. Conservation efforts would face significant challenges. The animal's space requirements would conflict with human settlements and agriculture. The species' aggressive temperament would make zoo management extremely difficult, as seen with the challenges of keeping modern rhinos in captivity. Additionally, its grazing habits would likely devastate crops and compete with livestock for resources. From an ecological perspective, the disappearance of the woolly rhinoceros marked the end of a specialized Ice Age ecosystem. While its extinction represents a loss of biodiversity, the modern world is better suited to smaller, more adaptable species. The woolly rhinoceros serves as a powerful reminder of how climate change can eliminate even the most well-adapted creatures when conditions shift too rapidly. Contemporary humans can appreciate this magnificent beast through fossils and cave art, while recognizing that our current landscapes and safety benefit from its absence. The fossil record of the woolly rhinoceros provides valuable insights into Pleistocene ecology while underscoring the fragility of even the most imposing species when faced with environmental upheaval. Deinosuchus. During the late Cretaceous period, approximately 82 to 73 million years ago, North American waterways were ruled by a prehistoric crocodilian that made modern saltwater crocodiles appear tame. Deinosuchus, whose name translates to terrible crocodile, was an apex predator capable of reaching lengths of 12 meters and weighing up to 8,500 kilograms. Fossil evidence reveals this monstrous reptile possessed one of the most powerful bite forces in natural history, estimated at 18,000 pounds per square inch, strong enough to crush bone and even pierce through the armored plates of dinosaurs. Unlike any crocodilian alive today, Deinosuchus specialized in hunting large terrestrial prey, including hadrosaurs and theropods that ventured too close to the water's edge. The physical characteristics of Deinosuchus were engineered for predation on an unprecedented scale. Its skull alone measured nearly 2 meters long, wider and more robust than any living crocodile. The creature's teeth were massive, conical, and designed for gripping rather than slicing, perfect for dragging struggling prey underwater. Recent studies of bite marks on dinosaur bones confirm Deinosuchus frequently attacked large ornithopods like Appalachiosaurus, with some fossils showing evidence of healed injuries from failed predation attempts. The animal's vertebrae suggested had a more flexible spine than modern crocodilians, potentially allowing it to perform death rolls with multi-ton dinosaurs as prey. Deinosuchus inhabited a vast range across what is now the western interior seaway of North America, from Montana to northern Mexico. Fossil specimens have been found in both marine and freshwater deposits, indicating it could thrive in various aquatic environments. Unlike contemporary crocodilians that primarily ambush prey at the water's edge, Deinosuchus may have been an active hunter capable of short bursts of speed on land. Its growth patterns, determined through bone microstructure analysis, show it reached sexual maturity at around 35 years, but continued growing throughout its lifetime. Some specimens suggest individuals may have lived for over 50 years. The hunting strategy of Deinosuchus combined brute force with sophisticated predatory behavior. Fossilized dinosaur bones with distinctive puncture marks indicate it often attacked by first crippling limbs with crushing bites before dragging prey into deep water. The predator likely employed a technique similar to modern crocodilians, clamping down with incredible force, then spinning rapidly to dismember prey. However, at such massive sizes, even a single bite could prove immediately fatal to most dinosaurs of the time. Paleontologists have discovered hadrosaur tail vertebrae with Deinosuchus bite marks, where the spinal cord was completely severed in a single chomp. The extinction of Deinosuchus occurred several million years before the Cretaceous-Paleogene asteroid impact that wiped out the dinosaurs. The exact causes remain debated, but changing sea levels and the disappearance of its preferred coastal habitats likely played significant roles. As the western interior seaway receded, the ecosystems that supported such massive aquatic predators collapsed. Smaller crocodilians survived by adapting to freshwater environments, but the ecological niche for a dinosaur-eating superpredator vanished forever. Modern ecosystems would be incapable of supporting a predator like Deinosuchus. Its size and dietary requirements would devastate aquatic and terrestrial animal populations. The creature would view large mammals, including humans, as potential prey, making any waterway within its territory extremely dangerous. Infrastructure near rivers and coasts would face constant threat, as an animal of such mass and power could easily damage boats, docks, or even small buildings. The ecological balance of contemporary crocodilian species would be completely disrupted, as Deinosuchus would outcompete them for food and territory. From an evolutionary perspective, Deinosuchus represents the pinnacle of crocodilian predatory adaptation. Its disappearance allowed other aquatic predators to diversify and ultimately paved the way for modern ecosystems to develop. While fascinating as a fossil specimen, the world benefits from its absence. The Cretaceous period may have been the age of dinosaur-eating crocodilians, but modern humans can appreciate these terrifying predators from a safe distance, through the fossil record rather than personal encounter. The legacy of Deinosuchus serves as a humbling reminder of nature's capacity to produce perfect predators, and the impermanence of even the most dominant species when environmental conditions change. Estemmenosuchus. During the Permian period, approximately 267 million years ago, long before dinosaurs dominated the Earth, a truly bizarre mammal-like reptile roamed the ancient landscapes of what is now Russia. Estemmenosuchus, whose name means crowned crocodile, was unlike any creature alive today. A massive, heavily built herbivore adorned with grotesque antler-like horns protruding from its skull. These strange bony growths formed a distinctive crown, giving the animal an almost demonic appearance. Reaching lengths of up to 4 meters and weighing nearly 500 kilograms, this prehistoric oddball belonged to an extinct group called Deinosuchus, which included some of the earliest large land animals. The most striking feature of Estemmenosuchus was undoubtedly its skull ornamentation. Multiple sets of thick, bony projections extended outward from its head, some upward like antlers, others sideways like bull horns. Scientists debate their purpose, with theories ranging from sexual display to species recognition or even thermal regulation. The creature's wide, powerful jaws contained both sharp front teeth and grinding molars, suggesting an omnivorous diet that likely included tough vegetation, roots, and possibly small animals. Its barrel-shaped body and short, sprawling legs indicate it moves slowly, perhaps spending much of its time wallowing in swampy areas like a prehistoric hippopotamus. Estemmenosuchus fossils have been found exclusively in the Perm region of Russia, dating back to a time when the area was a lush, riverine environment. The climate was warm and humid, supporting dense forests of primitive conifers and ferns. This ecosystem teemed with other strange Permian creatures, including predatory therapsids and giant insects. Analysis of bone structure reveals Estemmenosuchus grew rapidly, reaching adult size within a few years, an adaptation that may have helped it avoid predators during vulnerable juvenile stages. The animal's thick skull bones suggest individuals may have engaged in head-butting contests, similar to modern musk oxen, though its exact social behavior remains mysterious. The extinction of Estemmenosuchus coincided with the catastrophic end Permian mass extinction, the most severe die-off in Earth's history. Volcanic eruptions in Siberia triggered global warming, ocean acidification, and oxygen depletion, wiping out nearly 90% of marine species and 70% of terrestrial vertebrates. As temperatures soared and ecosystems collapsed, specialized creatures like Estemmenosuchus, adapted to very specific environmental conditions, disappeared completely. Smaller, more adaptable relatives survived and eventually evolved into mammals, but the Deinosuchus left no living descendants. Modern ecosystems would struggle to accommodate a creature as strange as Estemmenosuchus. Its size and dietary needs would put tremendous pressure on vegetation, while its territorial nature could make it dangerous to approach. The animal's bizarre appearance and potential aggression would make it a significant hazard in any human-populated area. Conservation efforts would face unique challenges. Imagine attempting to manage a herd of 500-kilogram horned reptiles with unknown social structures. Even if not directly threatening to humans, its ecological impact would likely disrupt existing food chains and habitats. From an evolutionary perspective, Estemmenosuchus represents an extraordinary but ultimately doomed experiment in terrestrial life. Its disappearance, while part of a global tragedy, allowed for the rise of more adaptable creatures that would eventually give rise to dinosaurs and mammals. The Permian period demonstrated nature's capacity for creating truly alien-looking life forms, but also how vulnerable such specialized species become during environmental crises. While paleontologists marvel at Estemmenosuchus fossils as windows into a lost world, modern humans can appreciate that such bizarre giants no longer roam the earth. The creature's fossil record serves as both a testament to evolutionary creativity and a reminder that even the most distinctive species are not immune to extinction when the world changes around them. The legacy of Estemmenosuchus continues to influence science, providing insights into early terrestrial ecosystems and the origins of mammal-like reptiles. Its unique anatomy challenges our understanding of prehistoric life, showing how different ancient animals could be from anything alive today. However, its extinction underscores the importance of adaptability and evolutionary success, a lesson that remains relevant as modern species face climate change and habitat destruction. While fascinating to study, the world is likely better off without 4-meter-long crown-headed reptiles wandering its swamps and forests. The Permian may have been the age of Estemmenosuchus, but its absence today is something for which both ecosystems and humans can be grateful. That's all for now, folks. Sweet dreams and see you next time.